Hello everyone, this is R. Vahita, Assistant Professor of Computer Science and Engineering Department from Rohini College of Engineering and Technology. I'm here to discuss some concepts about cloud computing. Let us see the topic on demand provisioning. Resource provisioning means the selection, deployment, and runtime management of software. Example maybe database server management systems, load balancers, and hardware resources, which may be example a CPU, storage, and network, for ensuring the guaranteed performance for applications. Resource provisioning is an important and challenging problem in the large-scale distributed systems such as cloud computing environments. There are many resources provisioning techniques which may be both static or dynamic, each one having its own advantages and also some challenges. These resource provisioning techniques used must meet quality of service parameters like availability, throughput, response time, security, reliability, etc., and thereby avoiding the service level agreement violation. There are two types of provisioning: static provisioning and dynamic provisioning. Static provisioning for applications that have predictable and generally unchanging demands or workloads, it is possible to use the static provisioning effectively. With advanced provisioning, the customer contracts with the provider for services. The provider prepares an appropriate resources in advance for the start of service. The customer is charged a flat fee or billed on monthly basis. And in dynamic provisioning, in case where demand by applications may change or vary dynamically, it is used. The dynamic provisioning techniques can be suggested where the virtual machines may be migrated on the fly to new compute nodes within the clouds. The provider allocates more resources as they are in need and removes them when they are not. The customer is billed as pay per use basis. When the dynamic provisioning is used to create a hybrid cloud, it is sometimes referred to as cloud bursting. The parameters for resource provisioning are response time, minimized cost, revenue maximization, fault tolerant, reduced SLA violation, reduced power consumption. Response time. The resource provisioning algorithm design must take minimal time to respond when executing the task. Minimize cost. From the cloud user point of view, cost should be minimized. Revenue maximization. This is to be achieved for the cloud service provider's view. Fault tolerant. The algorithm should continue to provide service in spite of failure of nodes. Reduced SLA violation. The algorithm design must be able to reduce the SLA violation. Reduce power consumption. The VM placement, that is virtual machine placement, and migration techniques must lower the power consumption. Thank you.